Here we are discussing an interesting question from the chapter binary operations. Here question is, considering the set A having elements -1 and 1 with multiplication operation is multiplication. Prepare its composition table and show that closure property, commutative law, associative law, existence of identity and existence of inverse are satisfied. Okay, so first of all we have to form a composition table, then we have to show that these 5 properties are satisfied with the operation of multiplication in this given set having elements -1 and 1. Okay, so first of all we'll form a composition table. Here set A is having elements -1 and 1 and operation is multiplication. So now let us form composition table. Composition table. So here 2 elements are here. So in the row we will write these 2 elements -1 and 1. Okay. Similarly in the column you write these 2 elements -1 and 1 like this. Here multiplication operation is here. So -1 into -1 is 1, -1 into 1 is -1, 1 into -1 is -1 and 1 into 1 is 1. So this is called composition table, correct? Very simple. Now we have to show these properties are satisfied. First, closure property. So -1 and 1, this set is a subset of integers. This set having elements -1 and 1 is a subset of set of integers, and we know that integers are closed with respect to multiplication. That is, multiplication of 2 integers is always an integer. Multiplication of 2 integers is an integer. Here in this composition table also we show that multiplication of elements of set A are from this set only, 1 -1 -1 1. So here this operation is closed in set A having elements -1 and 1, because you see composition table are having only these 2 elements -1 and 1, not other than these 2 elements, so this is closed. And second, we have to show that this is commutative. So commutative is checked by showing that here first row is exactly similar to the first column. Here in first row 1 -1, in first column 1 -1. In second row -1 1, in second column -1 1. So when rows coincide with the corresponding column, then operation is commutative. Okay, so here rows coincide with the corresponding columns. Therefore, this operation is commutative. Okay, now next we have to show that this operation is associative also. As we discussed previously, these are integers, and we know that integers are associative with respect to multiplication. We know integers are associative with respect to multiplication. So particularly set A having elements as integers -1 and 1. So therefore this operation is associative in the set A. Clear? Now we have to find the identity element, and we have to show that identity element existing here. So let us see fourth identity element. Okay, so you know that when we multiply these elements with 1, these elements will remain unchanged. You see this element 1. When 1 is multiplied with -1, we are getting same result -1. When 1 is multiplied with 1, we are getting same result 1. So here we can write 1 operation -1 is equal to -1, and 1 operation 1 is equal to 1. Therefore 1 is identity element. So identity element is existing here. Now last we have to find inverse. We have to show existence of inverse. Okay, are satisfied. So here inverse of -1 is -1 itself, as -1 operation -1, that is -1 into -1, this is equal to 1. 1 is identity element. Okay, and inverse of 1 is 1, as 1 operation 1 is equal to 1 into 1, this is equal to 1. This is also identity element. Okay, so this is the condition of inverse element, that when inverse element is operated with any element, we will get identity element. Okay, so in this way we are showing that all these 5 properties are existing here, and we have formed this composition table also. Okay, so very interesting and important solution. Hope you have understood it. Remain in touch with these videos, and please subscribe this channel if you have not subscribed, and share this video with your friends also. Wish you all the best.